Right now, today, the next example is we are going to find out the new position of the center of gravity of an object if a part of that object is going to be removed from that initial object. Right. So this question is about a disk which has a radius of 2r, a uniform disk. From that large disk, circular disk, they are removing a smaller circle which has a radius of r. They have removed it. So the question is, what is the distance to the center of gravity of the new part? You can see the new part. The black part is a hole here. Nothing is there. So we have to find the distance to that new center of gravity from the center of the larger circle. So this x is what we are supposed to find out. This x is what we are supposed to find out. Right. So how do you do this? First, you cut the object. The object is separated, remove part, and then what you do is, first of all, let's compare the masses. Now there are three different objects. One is the large circle, one is the small circle, one is the part where the smaller circle is removed. The part where it was small part is removed. So these are sheets. Therefore, the mass must be compared with area. That's why I have written this equation: mass is equal to area into areal density. Therefore, I can say mass is equal to area, K into A, something like that. K into A. If you take areal density as K, you can take it as a constant. Let's start with M1. Now for M1, what should I write? M1 is equal to areal density is K. Areal density is K. So I have to say K. And what is the area of that? K into pi 2r squared. Then what is it? It's going to be 4k pi r squared. All right, fine. And then let's write M3. What is M3 now? What is M3? M3 is going to be k into pi r squared. It's just k pi r squared. So I'll take k pi r squared as m. That's easier. And 4k pi r squared should be taken as 4m, is it? Fine. Now let's write the mass of this part, where this part, once small circle is removed from the large circle, what is the mass of that one? Right, that is easy. M2 is equal to M1 minus M3. Hope everyone will agree with me on that. M1 minus M3. Now for M1, we have taken 4m. For M3, we have taken m. Therefore, M2 is 3m. That is the mass of this part. Mass of the larger circle is 4m. Mass of the smaller circle is m. Therefore, mass of this part has to be 3m. Done. Then what you do is you put this small circle back here. You put this small circle back here. I will explain that with a diagram. I think you will get it. Right. You put that small circle back to where it was initially. Right. Where was it? Right. Put it here. Let's put it back. So once we put it back, it will look like this, na paper. Once you put it back, it will look like this. See if you can agree with me. Right now, I have put it back. Correct? I have put it back. So it will look like this. Only the outline will be visible. Now, here we have not cut, and now we have cut. So the outline will be visible like this. Right? It looks like the whole circle, but it's in fact a combination of two objects. So both the objects are put back together. Now, even though it looks like a single object, it is a collection of two objects. Therefore, I will mark the masses now. This is the small circle, which is m. And here there is another mass, that is the outer part, or the other part, that is 3m. All right. Hope you understood. This is m. What is m? The small circle. 3m is the remaining part, the mass of the remaining part. Right. And this is the new center of gravity, G0. And this is the center of the circle, O. Okay. And what is the distance? What is this distance, people? What is this distance? This distance is actually r, isn't it? It's r. We need to find out this distance, x. We need to find out x. Okay. Two objects are there. One is the small circle and the other part. Small circle has a mass of m. The other part has a mass of 3m. And the distance to the other part, the center of gravity of the other part is x. Distance from the center of the large circle to small circle center is r. So here you can finalize it like this. Look carefully, look closely. you can say x over r. What is x over r? X over r is m over 3m, because two masses now 3m and m are put together, 3m and m, and what is the center of gravity of those two, 3m and m? It should be at O, correct? When you put 3m and m together, you will get the first circle once again. So when 3m and m are put back together, this is the what combined center of gravity. So from the combined center of gravity, x to r should be m m to 3m, therefore it is 1 over 3. So finally x will be equal to r by 3. That is the final answer. X will be equal to r by 3. So now we know, qualitatively we know, when you remove a part from the right side, center of gravity will shift a little to the left side. Okay, through this example we have found it quantitatively what exactly the value is. Okay, so you put the object back together, you mark the masses, and then you take the distance from the center to each mass. X is to r should be 1 is to 3, because the mass ratio is 1 is to 3. So the final answer is r by 3. Right, next question. As shown below, a circular disc of radius r was, circular part of radius r was removed from a uniform circular disc of radius 4r. Find the distance to the new center of gravity from the center of the circular disc of radius 4r. Right, now this is the circular disc. From that we have removed a small circular part like this. Therefore, initially the center of gravity will be here. This is where the initial center of gravity will be. I'll take it as G0. Now the new center of gravity would have, from G0's position, would have moved a little towards left. I'll take it as G. Why? We are removing mass from the right side. Therefore, center of gravity will shift a little to the left side. And there will be three parts which we will have to take into consideration. One is the large circle, and the other one is the small circle, and the other one is the remaining part. Okay, right. The center of gravity of this, fine. Let's take the masses now. Mass of this, we'll take it as m1. Mass of this part, we'll take it as m2. And mass of the small one, we'll take it as m3. And remember, the radius of that is r. Fine. Quickly, the masses must be compared based on area. So I will write mass is equal to areal density into area. Areal density into area. That way you can compare it easier. M1 is equal to areal density multiplied by area is pi into 4r square. That is 16 pi kr square. That is the mass of the larger circle. And mass of the smaller circle M3, what is that going to be? K, areal density multiplied by area is pi r square. Therefore, that is K pi r square. So K pi r square, for our convenience, let's take it as M. 16 pi K r square, let's take it as 16M. Therefore, what is the mass of the remaining part? M2 is equal to M1 minus M3, that is 16M minus M. Final answer, 15M. That is the mass of this remaining part, 15M. Right. Then what do? We put that small circle back to where it was initially. We put it to where it was initially. So, yeah. This is what's going to happen. Fine. And if I put it back to where it was initially, it will look like, the diagram will look like this. Hope everyone can agree with me on that. This is how it will look like. Now, we have put that small circular part. So when you put it back, it will, yeah, right, fine. You will have this. Now you have two objects together. This is the center. Remember, this is the center G, G0 actually, G0. And we have a mass here. What is that? That is M. And we have a mass here. And what is that? That is 15M. That is 15M. And we don't know the distance to that. I'll take that distance as X. Now carefully tell me, what is the distance from G0 to M? That's the most important thing. What is the distance to M, center of gravity of M, from G0? What is this distance? Right. Let's get some answers. Yep, that will be 3R. Exactly 3R. Yes, that will be 3R. All right. So from the center of gravity, now when you put the small circle back, you have the large circle again. So the new center of gravity of the combined object now, this 15 m part and m part, it will be again at the center of the large circle. So what is the ratio we are going to use? What is the ratio we are going to use? Right, the ratio is going to be this. X over 3r, that is the distance, ratio between the distances. X is to 3r is going to be m is to 15m. M is to 15m. X is to 3r is going to be m is to 15m. All right. So I'm getting 1 over 15 here, 1 over 15. Therefore, x is equal to 3r over 15. Therefore, final answer for x is going to be r by 5. R by 5. It's going to be R by 5, not R by 15. I received some answers R by 15, but unfortunately that's incorrect. I think instead of 3R here, you might have substituted R instead of 3R. That's where the mistake might have happened. The correct answer is R by 5.